Thank you all for taking time out of your busy schedules today to attend today's webinar, which is entitled The Coming 100 Gigabit Ethernet Invasion and Beyond. My name is Jon Toigo, and I'm the chairman and co-founder of the Data Management Institute and managing principal partner of Toigo Partners International, a technology advisory and consulting firm. I'm delighted to be talking to you today about this subject, mainly because I believe the real value of networking bandwidth improvements is not what the vendors of switches and routers and the like prefer to talk about, which is to say the ability they afford to aggregate a lot of edge traffic into mid-tier and core switch fabrics. That strikes me as a bit of a yawn. Instead, I think that the improvements in bandwidth are almost certainly going to enabling a refresh of other technologies, particularly in the server and storage space. And above all, they tend to be driven by a killer application, and that seems to not be getting the amount of discussion that it needs to get in order to really build a good business value narrative for 100 gigabit Ethernet. So anyway, I'm going to talk about this for about the next 30 to 45 minutes and hopefully offer you a perspective that will be useful in your own planning efforts. I'd like to thank Starwind Software for providing me with this forum to voice my views, and frankly, I have a bit of tech fatigue. I think probably everybody does right now. The industry keeps promising us a big bang in information technology. We keep getting we keep being promised revolutionary improvements, and instead we get evolutionary improvements. Someone smart once told me that the basic elements of a von Neumann computer are in a constant game of leapfrog. For a time, storage is the fastest component. At other times, it's the bus or the interconnect or the network. And at other times, the CPU is faster than the other two. And what we're about to see right now is a jump in bandwidth and throughput in networking, 100 gigabit Ethernet. Vendors will no doubt want to contextualize this as a big bang. I don't know whether they're going to resonate much with that pitch, again, because of tech fatigue. But there are some significant reasons to pay attention to the evolution in Ethernet, and I want to look at them here. So my objectives for this briefing are threefold. We'll look at what 100 gigabit Ethernet is. We'll look at the standards that provide the underlayment for all the products. Then we're going to try to sort out the value case for 100 gig E, and not just the narrative around improved networking performance that most of the industry is advancing currently, but the real business value of the technology going forward. And of course, as I always do, I'm going to try to separate the marketecture from the architecture so you can wade into the industry conversation about 100 gig E without feeling out of your depth. And of course, I'm going to try to accomplish all this in 30 to 45 minutes. So let's start with a quick overview of the standards behind 100 gig E. Actually, the quest for 100 gigabit per second Ethernet was first discussed back in the 1990s, as I recall, about the time the industry was pursuing 10 gigabit per second links to deal with what they saw as imminent need in the Internet during its period of commercial growth. Even then, some believed that 10 gigabit per second Ethernet would be insufficient to meet requirements, and there was already talk about 100 gigabit. But it seemed to be out of the reach. And there was general agreement, a confidence, if you will, among the industry that Moore's law, which applied to chips, would also apply to transmission rates and to Ethernet generally, and that 10 gigabit Ethernet would double its bits per second in 1.5 years, and then double again 18 months later, et cetera, just as chip clock rates were doubling. In fact, it took almost 15 years for the industry to regroup and to create 100 gigabit Ethernet standard. Now, common engineering and commercial arguments for advancing to 100 were to reduce the number of optical wavelengths that were used and to slow the rate at which new fiber cabling needed to be deployed. And secondly, to use bandwidth more efficiently than was possible with 100 gigabit per second link aggregators. And finally, to provide a cheaper wholesale peering and data center interconnect connectivity solution. So it was all pretty much about the money, and also a lot of the vendors were anxious to skip over relatively inexpensive halfway measure called 40 gigabit per second technology. Interestingly, 802.30BA, which was introduced by IEEE in 2010 after 4 years of working group meetings, produced both a 40 and a 100 gigabit Ethernet standard, 2 link definitions in one standard. That was a first for the IEEE. A lot of folks have forgotten 40 gigabit Ethernet at this point, but the first real work that was done on matching high-speed Ethernet to single-mode fiber was centered on delivering 40 gigabit Ethernet over that physical medium. That's 802.3BG if you're looking at standards. Now, subsequent standards built on that particular standard to produce a 4-lane physical layer specification for single-mode backplanes and for twin-ax copper. That's 802.3BJ. That was for the copper specification. And then 4-lane electrical interfaces for operating on multi-mode and single-mode fiber optic cables. That's 802.3BM. Now, if this is all over your head, don't worry about it. You don't really need to understand this. Without going into too much of the weeds, the real function of all these standards was to basically standardize transceiver types and link lengths. The final 802.3BM standard was approved just last year in February 2015 with a comprehensive specification covering all the componentry and interfaces that were required to make switches and routers and NIC cards and motherboard implementations all work together. So that's what the industry says is coming soon to a data center near you, is a whole new set of transceivers and kit that will allow you to do 100 gigabits per second. Now, some of you may be saying, what? We were just starting to deploy 10-speed gigabit. The industry has this workable 100 gigabit Ethernet networking standard, but what do you do with it? I mean, they threw it out there as the next big thing in networking and traffic aggregation and management, and that's important to be sure, but it's actually just in time to meet the needs that are starting to develop in cloud environments and large data centers, but that aren't really in our face yet. Let's look at it a little more closely. It took everybody about 15 years to start adding 10-speed gigabit Ethernet to their data centers. Motherboards with integral 10-speed gigabit Ethernet network adapters on board have just started to appear in high-end servers. Frankly, there's a big question out there whether 100 gigabit Ethernet is coming to market at the wrong time, or whether it can be sold simply as an improvement to networking. In my humble opinion, there are a lot of very good reasons to be interested in 100 gigabit Ethernet besides its potential contribution to networking efficiency. I've summarized them into 5 bite-sized arguments in the following slides, and you can feel free to use them as your talking points when you're at your next networking geek soiree. Perhaps you'll find yourself suddenly tagged as hip and cool in all the Facebook posts or whatever the current social media aggregator is of choice. Now, talking point number 5 is basically what the industry says. The reason for 100 gigabit Ethernet is network bandwidth aggregation, but I see this statement as something of a big yawn. Yes, there's been a steady progression of Ethernet standards since 10 base T to 10 speed gigabits per second, but that tick-tock has proven a bit of a laggard since then. As I said, it took 15 years to do a 10x improvement in the speed of Ethernet, and even with all the intermediary standards work, the whole roadmap slowed down to the point where interest waned. The situation is somewhat analogous to U.S. space exploration. Does anyone remember the mission objectives of Apollo missions that followed the Apollo 11 moon landing, or any of the space shuttle missions at all, except for perhaps the tragic ones? There is a very good study online about the decline of positive mentions and headlines and TV news accounts regarding post-Apollo 11 missions and corresponding decline in audience for all of these events when they had become somewhat routine. And in some respects, Ethernet networking improvements have fallen into the same tragic pattern here. So yes, 10-speed gigabit Ethernet is here. It took a while for it to arrive, and a lot of companies are just deploying it. And yes, 100 gigabit Ethernet can improve the capabilities of data center networks, but one needs to wonder whether that fact alone will be sufficient to sell the cost of upgrading your networks to those who control the purse strings in the front office. All right. Now, I know you say almost certainly that the need for capacity had better be understood, and that's true. The front office had better understand it, because we're going to run into a big problem with cloud technology if they don't. In terms of internal data networking switches, the adoption of virtualization plus the increased native deployment of 10-speed gigabit Ethernet NIC ports on server motherboards, those are all going to increase the pressure on distribution switches, which are those mid-tier switches in a lot of networks that aggregate traffic, and also to a certain extent on core switches that provide inter-networking services. And basically what we're going to need is a way to increase bandwidth handling capabilities. Now, for as long as these types of hierarchical networks predominate, capacity is going to be one of the gating factors on improving your data center's performance and speed, and certainly improving the resiliency and reliability of your cloud-based services. So there are options, by the way, that we won't go into on this talk that maybe are a little bit different than using Ethernet, but for now, Ethernet is mainstream. And you know, all the trends that we're seeing, both the servers transitioning from 1 gigabit Ethernet to 10, and especially virtual machine hosts, and then mounting pressure for more aggregation capacity in the 40 gigabit and 100 gigabit Ethernet switching infrastructure. Those things are with us today, so there's no speculation there. And basically what we're talking about here is hybrid data centers, which is really the kind of the current nom de plume, not non de plume. It's currently the strategy that companies claim that they're pursuing right now. They're adding connections to cloud-based services, which is that little cloud icon down below the distribution switches. And that's basically so they can obtain additional services outside of their on-premise data center from cloud service providers. Now, the impact on distribution switches for all these on-premise metropolitan and wide area network connections is going to create, simply put, another driver for doing more in the area of switch bandwidth aggregation and improvements in distribution switch speed. Now, here, for those of you who are new to this whole concept of hybrid data center, I decided to build a little diagram for it. If you notice, here's your data center of the future, or in many cases, data centers companies already have in place today. We call it a hybrid cloud data center because basically they've created within their own environment a cloud, and then they're referencing external public clouds for certain kinds of services, whether it's infrastructure as a service or DR as a service. The story thus far is that we have a whole bunch of customers running around with mobile devices. One company, IBM, calls these systems of engagement. They peruse catalogs. Think Amazon. They're out there looking through a catalog ordering system, and they see the pair of shoes that they want or what have you, and they send a request via their app into systems of interaction, which are generally very virtualized systems inside the data center, where the incoming requests are received and they're initially processed. And of course, to verify who they are, we flip their request or maybe their credit card information over to systems of insight, which currently are big data analytics platforms, usually comprised of clustered servers together. They validate the purchase and the payment details. They scan the customer's account profile, and they look for ways to sell them additional stuff. So they have a memory of what he's bought from the company in the past, and they can come back to him not only with approval of his credit card order, but also with oh, by the way, since you're here, you like these shoes, you may want to buy some socks. We have some socks on sale. So they sell socks with the shoes, and that's basically how business is done. Now, the cool thing about this is that it generates what's known as a starburst effect. Every order that's placed or every transaction that's processed by the systems of insight, systems of interaction, system of engagement produce about 100 transactions on the back end, where they're talking to databases, systems of record, These are legacy systems for the most part. They're high-performance transaction processing environments, and their job is to do enterprise resource planning, logistics planning, customer relationship management, finance and accounting, all the things that are the core systems for any company. These are where the real money is made for the company, by the way. The front end is all a driver of transactions, but the transaction processing actually occurs in the back end. A lot of that is older technology. A lot of it is not cloudified right now. But basically, this is your standard traditional infrastructure for a hybrid data center. When you run out of space, when you need more storage, when you need more compute, you can go out to public infrastructure as a service providers and basically add their capabilities to the corporate capabilities and get the additional processor, the additional storage, the whatever additional resource you need that way. And then, of course, you're going to have to protect all this data, and increasingly companies are looking at cloud service providers to deliver DRaaS, disaster recovery as a service. All right, so this process repeats millions and millions of times. Your miracle workers, whether your bosses appreciate it or not, the owners get rich, the customers say nice things about the company on social media, the business thrives, and everybody lives happily ever after, and that's the end of the movie. All right, that's the golden dream of the hybrid cloud data center, and it's becoming more and more a reality in more and more companies today. Chances are it's in your company as well. And as I said, one of the things that that is driving the need for increased bandwidth is the increased use of devices, usually appliances that interconnect us, or gateways that interconnect our on-premise infrastructure with cloud-based infrastructure and cloud-based software as a service, which are becoming much more popular as an adjunct to your on-premise capabilities, driving more bandwidth demand. That goes with the old philosophy of build your base and buy your burst. You're going to basically provision your data center for basic requirements, but you're going to have to buy additional services from a cloud service provider to deal with periods of high activity, that sort of thing. Okay, now number 3 talking point is that there's an increased perception now because of the reliance on big data and the reliance on the smooth operation of all these transactions on the need for disaster recovery and data protection. I was surprised and actually delighted to read a report that came out from Actual Tech right around the time of World Backup Day in March that specified that the 3 leading things that initiatives that companies were planning for their IT departments this year were, number 1, improved data security, number 2, improved governance, risk, and compliance, making sure all their data is in compliance with government regulations, and number 3, disaster recovery and data protection. So what are they doing about it? Well, a lot of them are basically trying to outsource the disaster recovery and data protection process to DRaaS providers. So they drop in appliances that serve a function of gateway, or they sometimes call them backup servers, or sometimes they call them virtual tape libraries. In fact, Starwind Software has a nice VTL that's built right into their hyper-converged infrastructure, their software-defined storage, if you will. It does a very good job, and it's easily deployed. These provide connectivity, a channel, if you will, that must go through your switched infrastructure and connect up with your cloud service provider. In the case of the VTL from Starwind, one of the major cloud services now, you can get that virtual machine that is the VTL right out of the App Store in the Microsoft Azure cloud and load a companion device to talk to your local device immediately. It's kind of a cool solution, very slick. Anyway, the DR as a service guys and cloud-based backup are the modern hot site for those of you who are steeped in DR. They're commercial facilities for placing data copies theoretically out of harm's way and for failing over key virtual machines in the event of an outage. Now, these strategies are increasingly in need of bandwidth aggregation between the backup appliances and the subnetworks and distribution switches, and also between the distribution switches and the cloud-based services. So cloud-based data protection and disaster recovery services, as they become more popular, are again driving more bandwidth demand. This is all adding up to a pretty powerful case for why you need 100 gigabit Ethernet just to keep everything glued together in the infrastructure that you have today. Now, the last point I want to get to is in-memory. In-memory databases are all the rage, and maybe that's why we need to start thinking a little bit like futurists. I mean, when you think about it, all that disaster recovery stuff we were talking about before was for your virtual systems and for your maybe Hadoop or Apache Spark infrastructure that's doing big data. The truth of the matter is many of you know, databases are not being virtualized, and databases are, in fact, the key money makers for the company, and their data really does need to be protected in real time. And frankly, now that we're moving databases off of disk infrastructure and into memory, at least that's what SAP, Oracle, IBM, Microsoft, and a number of newcomers to the market want to do, we're creating even more challenges for ourselves for making very fast backups that don't interrupt operations for a very long period of time. Nobody's got the time in their calendars anymore. Okay, now that's a lot to absorb. I'll back into it a little bit here. Hold on. First of all, when you look at how we're deploying our technology today, this is an aggregation of some data points from IDC and from Gartner. They say that by the end of 2016, roughly 75% of all the workload we have in our data center will be running on 29% of our infrastructure. So servers that are hosting virtualized workload will comprise 29% of all the CPUs that we have deployed. Now, what's occupying all the other infrastructure? 71% of servers and other types of CPUs. Only 25% of our workload is loaded on those. Pardon me. That 25% happens to be the money makers. That's your legacy databases. That's everything that's driving the company's revenue streams on an ongoing basis. There's a big desire to get even more performance out of those legacy systems, and a big effort underway to migrate databases into in-memory configurations where they run entirely in the memory of the machine, so that when queries are made to data, there's no lookup made to a disk device. Instead, it goes out at memory speed, at bus speed actually, and obtains the data that it requires from the memory where all the data lives. It's kind of a cool idea, and newcomers are out in droves right now going for it as sort of an Uber threat to the companies that are already vested in legacy databases. You know, they're feeling pressure from companies like Mongo and GrigGain and a bunch of others. And frankly, SAP with its HANA application is trying to move not only real-time analytics into in-memory databases, they want to see the online transaction processing stuff migrate there as well. A lot of this has to do with complaints from customers that there simply aren't any windows to do batch operations anymore in their operational schedules, and there's a need for faster processing and greater scalability. So these are all good reasons to do something about it, to go in memory. And since we're talking about memory, we obviously have to talk about the latest advances in memory. Obviously, we're improving memory itself all the time. We're going to a whole new realm of non-volatile electronic memories. You can read about those on the web. But the big news right now is this emerging non-volatile memory host controller interface specification, MVM Express or MVME. In case you're not familiar with it, it's basically a standard interface for communicating with the non-volatile memories, the flash memories that are inside your environment. Imagine being able to extend a fabric of connections across multiple server chassis, so that you can basically unite a whole bunch of memory on different server devices in a common fabric. That's been sort of a dream that's been driving the NVMe folks for quite a while, and frankly, doing so is going to require inter-server link speeds of at least 100 gigabits per second, and that's at a minimum, so that 100 gigabit E can be seen as an enabler for next-generation server technologies and next-generation database platforms. You owe it to yourself to get, if you're not familiar with this, to get to know what is going on in the NVMe world, and also to understand that NVMe isn't just for PCI. I mean, it works, of course, across the PCIe bus, That's what it was originally driven to do. But as this slide, which is borrowed in part from an Intel presentation, demonstrates, there's a lot of interest now in usage models that go beyond the PCIe fabric and embrace alternatives such as remote direct memory access, RDMA, so that protocols like internet-wide area RDMA protocol, or IWARP, as well as InfiniBand and RDMA over converged Ethernet, or ROCE, can be used as a network infrastructure for tightly coupled systems. Again, this is a way to take a bunch of systems that are sort of clustered together and physically attach all of their memories into a common fabric, so that you think you're dealing with a constantly scaling and expanding sized infrastructure for that in-memory database. And that's definitely going to be required, especially for older databases that run on disk currently, that have a lot of extents and a lot of things that have been built onto them over time. Okay, so to summarize, support for highly scalable 100 gigabit Ethernet fabrics between building block servers and their memories enable a huge in-memory database on commodity hardware. And that's sort of a dream for providing big data analytics and in-memory OLTP at a price that the rest of us can afford, simply by using the most generic and most widely installed interconnect in the market, which is Ethernet. So it's pretty cool when you think about it. We might actually see supercomputers made out of our x86 Tinker toys in the not too distant future. All right, now with these 5 talking points, you're set to impress all your fellow geeks at your next soiree. In addition, you'll need to frame 100 gigabit Ethernet like every other technology in terms and language that non-technical folks in the front office understand if you're going to receive funding for initiatives to upgrade to 100 gigabit Ethernet. Remember, no bucks, no Buck Rogers. Now, to create a business value narrative, I won't dwell on this. It's going to require that you create a story for management that explains why you need this new technology upgrade. You need to do it in terms and language they understand. I always suggest that you take a lesson out of the Harvard Business Review and use one of their magic triangles. They have triangles that are used for business value case analysis for just about everything. So I borrowed one and I threw my own monikers on it. You need to basically tell management 3 stories. 1, how will 100 gigabit Ethernet deployment help you contain cost? 2, how will you reduce risk using this technology? And not just the risk of downtime, but also the risk of early obsolescence, or the risk of not getting the return on investment, or maybe the risk of a disclosure of data or a big mistake that exposes the company in an unflattering way in the front page of the Wall Street Journal. And then finally, improve productivity. Now, there are great arguments to be made in all 3 of these categories if you do go to the realm of 100 gigabit Ethernet switch fabrics in your environment. But you're going to have to create a narrative that doesn't emphasize speeds and feeds as much as it emphasizes what the business value is of what you're going to be deploying. Now, with that said, if there are any questions, I hope that you'll email them to me, or LinkedIn to them, or send them to me via Twitter, or even go to my blog if you want. But anyway, it's been a pleasure. I greatly appreciate the opportunity. And I also want to offer everybody, go over to Virtualization Review. We recently did a buyer's guide on hyperconverged infrastructure, and it's free for download, and Starwind software is in there, as well as many other providers of software-defined storage, which will also play a role in all of this 100 gigabit Ethernet based storage fabric building that we're going to be doing. Okay, thank you, and hope everybody has a good day for the rest of the day.